Welcome to multiple choice question 17 of the 2007 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. Now before we move on, I'd just like to point out that the use of a CAS calculator is by far the most efficient way to answer this particular question. But at the end of the video I will hang around and show you how to do this by hand if you want to see it done that way as well. So for question 17, it says the function f satisfies a functional equation f of x equals x for the maximal domain of f. The rule for the function f must be one of the following. So this is a problem where we can set it up on the CAS calculator and it will actually be able to judge which of these is the correct function. On the CAS calculator, go into the main menu. Next, we want to set up a situation where the calculator will judge this functional equation each time we press execute. So we're going to start by just typing in the rule for option A, which is f of x equals x plus 1. And then we're going to highlight that and go interactive define as f of x. And then the next thing we want to do is type out the functional equation after we've put judge before it. So we're going to go to keyboard, and then we're going to click the down arrow, and then in catalog we're going to go to J for judge, and then go input, and we want to judge if f of, and then inside it we also want f of x, so we want f of x to equal x. And then if I hit execute, that's going to tell us that it's false. So that is the f of x function x plus 1 doesn't satisfy that functional equation. So next what we're going to do is we're going to change the rule for f of x. So looking at option B, we want x subtract 1. So we change the rule, and then with the cursor up here in this line, we're going to hit execute. And it may not look like anything happened, but I did press execute and it came up with false again, which means we want to try our third option. So if I just get rid of that, and then we're going to put in a fraction, and it's going to be x subtract 1 divided by x plus 1, and then we can hit execute, and then it still comes up as false. So each time I am pressing execute, it's just that none of these have satisfied the equation yet. And then the third one, if I delete that out, is log e of x. So I'm going to use ln from the keyboard, so ln of x, and then again hitting execute, it says undefined this time, which is essentially another false statement. So it says that log natural or log e of x doesn't fit that functional equation. So hopefully part E, or the option for E, will give us a true statement. So if I put that in, we're going to have x plus 1 divided by x take 1. And when I hit execute, you can see that it rejudges that line and it says that it's true. So from the calculator, it tells us that the correct option is E for this question. And then if we have a look at the examiner's report, we can see that this was a poorly done question on the exam, with only 47% of students getting the correct answer for this question. And we can see that if you know how to set it up on a calculator, it's not too bad. And now what I'll do is I'll just bring the question up and I'll just go through how E is correct by hand. And you'll see that if you had have tried to do that for each one of these by hand instead of using the calculator, you can see how it would have taken a long time and that you probably would have ended up guessing an answer for this question. So we knew, just to reiterate, that E was the correct option. And that means that if I sub that into this functional equation, it should be true. So when we want to do these sorts of problems, you would start with the left-hand side equals, and f of x would involve putting x plus 1 over x take 1 wherever there's an x in the rule. So you'd end up with x plus 1 over x take 1 plus 1 on the top line divided by, and then there's an x there, so you'd put f of x into that spot, which would be x plus 1 over x take 1, and then subtract 1 on the bottom line. And then this would be equal to x plus 1 divided by x subtract 1 plus, and then we'd want a common denominator. So instead of adding 1, I'm going to add x take 1 over x take 1 on the top line. And then all of that is divided by x plus 1 over x take 1, take, and then instead of subtracting 1, I'm going to subtract a term with a common denominator, which would be x take 1 over x take 1 just there. And then we would have the top line of the fraction would be x plus 1 plus x take 1 would actually give 2x. And then it would still be divided by x subtract 1. And then that would be divided by the bottom line still, where you're going to have x plus 1 take x take 1. So that negative will affect the second negative 1 there. So you'd actually end up with x subtract x, which would give 0x, and 1 subtract negative 1, which actually gives 2. So you'd have 2 on x take 1 on the bottom line. And now instead of dividing by a fraction, we're going to actually multiply by the reciprocal. So we'd have 2x over x take 1, which is the top line, multiplied by the flip fraction of the denominator, which would be x take 1 over 2. And then you can see that the factor of x take 1 here and here would cancel. So this would simply give us 2x divided by 2, which just simplifies to give x, which equals the right-hand side of the functional equation. So once again, I just want to reiterate, that is such a long process to do by hand, especially if you have to test and try out multiple different options. It's far quicker to do that using the judge feature on our calculator.